Hello everyone, welcome to the Chapter 10 review. I'm Mr. Wagner, and if you are one of my students, as always, in your reviews I recommend that you try every single problem yourself first and then come here to get help on the ones you need. I certainly wouldn't expect you to watch every problem in this whole video. You can pause, rewind, fast forward as you see fit, unless you find watching the whole thing helpful as you prepare for a test. If you're another student here with another geometry teacher, or just out in the wonderful world of YouTube, trying to get better at things about area and surface area specifically as it pertains to geometry, hope you find this helpful. So let's check out these directions here. We're showing all work, receiving credits. If we're doing that, rounding all final answers to the nearest tenth, so one decimal place if necessary. First, for these problems, we're going to find the perimeter and area of each parallelogram or triangle. I am going through these problems for the first time here myself. I know how to do all the types of problems here, obviously, but if I make any mistakes, I will try to go back and fix what I've done and just make a note of that here. I have the key to look at, but I will do the problem first and then double check the key as I go along here. So let's check out number one. Here we are with a triangle, and we would know the area. We're doing perimeter and area here. So I'm going to start with the area. First of all is 1/2 base times height. And it looks like I know the base, it's right here, and I know the height. Perpendicular to the base is 12. So I can just go ahead and plug those things in directly. I've got 18 for my base and 12 for my height. And then from there, 1/2 times 18 would be 9. 9 times 12 would be 108. And then don't forget your units, they are important. We'd have millimeters squared on that one. And then for the perimeter, we would need to know what's the length of this side and what's the length of this side. So I'm going to call this X right here, and I'll call this Y right here. To find out what Y is, this length, looks like that's the hypotenuse of this right triangle right here. So I could say that 10 squared plus 12 squared equals Y squared. And that would be 100 plus 144 is Y squared. That means Y squared would be 244. So Y would be the square roots of 244. And I'm going to leave it like that for now. And if I'm trying to find what X is, I have this right triangle, the one I'm outlining right here. This would be 18 plus 10 for one of the sides, one of the legs, and then 12 for the other leg. So this looks like I'd have X squared. The hypotenuse squared would be 12 squared plus 18 plus 10 squared. And so we're looking at then X squared is 144. And then 28 squared. Looks like 28 squared would be, in some of these problems I'm going to be typing in my calculator as I go along here. That's a 144. Sorry, that didn't show up very nicely there, and it's still not great, but I think you can see what I meant there. And so if we take that plus 144, we'd have 928. Take the square root of both sides, and you have the square root of 928. So for your perimeter answer, I'll work this out off to the side here. Why don't I use the black pen here? So the perimeter would be all three of those sides added together. X plus Y plus this one, 18. So I'd have 18 plus X, which was the square root of 928, plus Y, which was the square root of 244. And putting that all into a calculator looks like gives me 64.11 millimeters. So on to number two then. I think this one will be a little more straightforward, a little quicker here. The area, I'll start with that once again. This is a rectangle now, so base times height instead of 1/2 base times height. So now we're looking at 18.5 times 9. And if I were to type that into a calculator, I should get 166.5 kilometers squared. And for some of these, I don't want you to think I'm just like super fast with the calculator. I am setting it up and then looking at the answer key to see what the calculator gave for that. The answer key is something another teacher had already made in advance, and so I'm just comparing my setup to that setup and then seeing what the answer should be after that. So for the perimeter, we're adding all four sides together here. and we have 9 plus 18.5 plus 9 plus 18.5. So you could write it all out. You could say exactly what I just said there, or you could write 9 times 2 plus 18.5 times 2, and it looks like this would be 37 together, and that'd be 18 together, so we've got a total of 55, and this is in just a length for perimeter, so just kilometers for that one. Number 3, it looks like we have for the perimeter, we're assuming this is a parallelogram. This is also a parallelogram, but it's a rectangle, which is just a special type of parallelogram. So if this is 7, that's going to be 7 over here. If that's 14, we're assuming this whole length from that vertex to that vertex is also 14. So I think I'm going to start with perimeter on this one. I'll continue to use red for perimeter and blue for area. I'll try my best to do that at least as I go through this. So I would have these things all added together, and it looks like that'd be 42, and yards is my unit. So 42 yards for the perimeter of that. The area of this is going to be base times height. That's the formula for any parallelogram. And so looking at the base, that's going to be 14. The height is the perpendicular part to the base. So we would have 14 times whatever that height is. So we need to do a little side work for that one. I'll use orange here for that. If this is 45 and then that's 90 making that 90, this is also 45 right here. And so if you use your ratios, I'll do the purple for the ratios. This was n, and n root 2 for that part. That means 7 is equal to n root 2. And so our height is going to be equivalent to n right here. So if we divide by root 2 on both sides, that means n, which is the same as the height in this case, is equal to 7 divided by root 2. Now, if this was a simplified radical form problem, I would tell you to multiply by root 2 over root 2, and you'd get 7 root 2 over 2, and then you could approximate that as a decimal to the nearest whatever. But because we are just approximating our final answers in the end of the nearest tenth, I can just plug that in directly right there and get my answer by using a calculator. So you could also have used trig to do this, but I saw this as, I think, the slightly easier way if you remember how 45, 45, 90 triangles work. So if I type in 14 times 7 divided by root 2 into a calculator, looks like that's going to give me 69.3 yards squared. 69.3 yards squared. And if you write YDS instead of YD, nothing wrong with that. I probably should be doing that here, but I think I'm okay either way there. For number 4, we are looking at, this one is a parallelogram. This is 5.5 down here. This is 4 over here since it's a parallelogram. We'll start with perimeter first again because I think that's a little easier once again on this one. 4 plus 5.5 plus 4 plus 5.5. Putting that together, I've got 11 for that, 8 for that, so that's 19 total. That would be feet right there. And then from there, the area, base times height once again. So on this one, we don't know what the height is. That's what we're going to be solving for here. H, I'll call it. This is a 30, 60, 90 triangle right here. That's 60, that's 90. That means this angle has to be 30. So those ratios were n for the short leg, n root 3 for the long leg, which is equal to h right here, n root 3, and then 2n for the hypotenuse. So that means 2n equals 4. You can divide by 2 on both sides, and that means n equals 2. That means h, which is n root 3, would equal 2 root 3. So I can take that, plug it in here. My base is 5.5. That's perpendicular to the height there. So now I have the answer, or the setup needed to get to that answer. So 5.5 for the base times 2 root 3 for the height. Put that into a calculator, and we should get our final answer on that one. And it looks like we got 19.1 on that if you round that off to the nearest tenth. So approximately 19.1 feet squared for that area. For number 5, this is a parallelogram still, but it's a square, a special, very specialized type of parallelogram. We'll start with area on this one. Base times height becomes 3.4 times itself. So if you just multiply 3.4 times 3.4, you have 11.6 rounded off to the nearest tenth. 11.56 I would also accept if you were one of my students. So 11.56 is saying to round in the nearest tenth if necessary. So I feel like this is an exact answer. It wouldn't really be necessary. So you could say that or this on that one if you're one of my students. And that would be meters squared, not meters. And then for perimeter, you could write 3.4 plus 3.4 plus 3.4 plus 3.4, or you could just write 3.4 times 4 because there's 4 of those sides. And then for that one, it looks like we've got 13.6 meters. Number 6, taking a look at, if this is 90, that's going to be 90 right there. And so that's 17, that's 17. I feel like this is superfluous information on this one. So we can just say area is 1/2 base times height. The fact that this is 13, I don't really care about that. Its base is 17. The height perpendicular to that base is also 17. So if you square 17, you get 285, and then you divide that by, or 289, you divide that by 2, and you get 144.5 inches squared. And then for the perimeter, again, this is, I don't really care about that information. It's just there to kind of throw you off on this one, quite honestly. This is n, this is n, and because this is isosceles, that means these have to be congruent. So that means these are both 45 and 45. So I know this is n root 2 right here. That's going to be needed to find my perimeter. So that means this side is going to equal 17 root 2. And so I would have 17 plus 17 plus 17 root 2 for my answer there. That's approximately, and you could plug that into a calculator, I'm getting 58.0 inches on that one. And for number 7, looks like we've got another 30, 60, 90 triangle here that could come in useful. This would be 30, this would be 20 for this length, and this length here and here. Looks like perimeter will be easier on this one to start, so we would just have 20 plus 30 plus 20 plus 30. Add all that together, and you've got 100 centimeters for your perimeter on this one. And then for the area, we would have, it's a parallelogram, so base times height, and we're looking for the perpendicular parts, base and height. So the base on this one I'm going to consider as this 20 right here. The height being perpendicular to that, connecting this base to this base, is whatever that is. So it's another 30, 60, 90 triangle. Short leg is your n part. Long leg is your n root 3 part. Hypotenuse is your 2n part. So that means 2n would be equal to 30. You can divide by 2 and say n equals 15, meaning that this part, your height, which is this n root 3 part, would become 15 root 3. So we would take that, plug it in here, and we have 15 root 3 times 20. So that'd be 300 times root 3, which is approximately, and let me just type that in the calculator here a second to double check. Yes, 519.6. So 519.6, and units are centimeters, so this would be centimeters squared on that one. Moving on to the next slide, it's the second half of your page there. We're looking at, hopefully, my page is going slow, there we go. The height of a parallelogram is 10 feet more than its base. If the area of a parallelogram is 1,200 square feet, find its base and height. So we're talking about area of a parallelogram. Start with the basic formula. Area is base times height. Plug in what you know to find what you don't. So if you've got the area is 1,200, replace A with 1,200. And the height of a parallelogram is 10 feet more than its base. So if I drew a little sketch of just a run-of-the-mill parallelogram where this would fit, this wouldn't be the best sketch. Let me adjust that a little bit. So the height is actually more than the base by 10 feet. So we're saying that this part here would be longer than this part here. So if I called this x from here to here, then this would be x plus 10. It would be 10 more than that. So I'm going to write this as x times x plus 10. Then we can multiply this together. This looks like a factoring problem to me. So we'd have x squared plus 10x equals 1200 if we distribute that x through. Subtract 1200 from both sides, and you are left with 0 equals x squared plus 10x minus 1200. Then you're looking for the factors of negative 1200 that would add to positive 10. So if we wrote out all the factors of negative 1200, I'll start with the factors of just 1200 first. We could do 1 and 1200, we could do 2 and 600, and 3 and 400, 4 and 300, and so on. But I'm going to skip some here. We want this sum or difference between these two to be 10, and then I'll figure out where the negative sign goes from there. So to me, it's looking like, boy, there's a lot of factors of 1200. Looking like we could go for quite a while, and eventually we'd get to 30 and 40. I'm noticing 3 times 4 is 12, and I add a 0 to both of those. That one's going to have a sum or a difference of, well, the difference is 10. That's what we need it to be, and we need it to be factors of negative 1200, and we need a positive sum. So negative 30 plus 40 would be positive 10. Negative 30 times 40 would be negative 1200. So that is exactly the combination we are looking for. We're looking for that combination here. So this would become 0 equals x minus 30 times x plus 40. Then we have two possibilities that would satisfy that equation as a solution to that. Plugging in right here, 30 would turn this factor into 0, which turns everything into 0, because 0 times who cares what this is 0. Plugging in negative 40 right there also works, but the problem with that solution is if you go back into the context of the problem, that makes this a negative length, negative 40. So it doesn't make sense in Euclidean geometry. We would cross that one out, and this is in feet. So 30 feet would be your answer for the base. This is going to be what your base is, your base length. The base length was x. And then your height is equal to the base plus 10. So you just do 30 plus 10 and say the height is 40 feet from there. Number 9 then, we've got the base of a triangle is 1/2 its height. So the base of a triangle, 1/2 its height. So we have another triangle that this is not drawn perfectly to scale by any means, but the height is longer than the base. So if I called this x from there to there, then I would be calling this, the height of that, 2x. It's twice as long. And so the area of a triangle is 1/2 base times height, and we know the area is 196. So plug that in, 196 goes right there. Your base is x, your height is 2x in this picture. Multiply it together. We've got 196 would be 1/2 times 2 would be 1, so this is just x squared. So then you can take the square root of both sides to get x by itself. The square root and square would cancel. So you got the square root of 196, and that is exactly 14. So and so that is your base. So I'm going to say 14 feet equals b for base. And then if I take that and I plug it in to find my height, the height is 2x, so it's 2 times 14, and that means the height would be 28 feet right there. And you may see, if you're looking at the handwritten key, that if you're one of my students this semester, when I'm first posting this, I'll be posting online, you may find the handwritten key might have in some problems a little bit different way to approach the problem or tackle the problem is what I have posted there. But what I have written here around the video might be a little bit different than what's posted there. But the answers in the end should be the same. It's just a different way to do the same problem. And so from there, let's find the area now. No more perimeter needed on these ones of each trapezoid, rhombus, or kite. So we're going to assume that these shapes are one of these three kinds of things. So we're going to make the assumption here that this one is a trapezoid. And the formula for that one, you might have seen it in a different way depending on what teacher you had. But I like to think of it as the average of the two bases. So b1 plus b2 over 2, which is really just the length of this midsegment times the height. It's really, if you think of the mid-segment, take this tiny triangle, put it over here, take this tiny triangle, put it over here. It becomes a rectangle that has just that base times height basic idea again. So this is B1 plus B2, length of the mid-segment. So you've got 15 plus 7.5 divided by 2. That's this base, and then the height perpendicular to those is 11. And so we're looking at 22.5 divided by 2, which would be 11.25 times 11. And if we multiply that, use a calculator for that, we're looking at 123.75 exactly. If you did not round, rounding not really necessary. What am I writing there though? I don't know what I'm writing there. Sorry, not 11.75. But I think I said it right. 123.75. That would be inches squared. Or if you round it off to the nearest tenth, 123.8. Also an acceptable answer there. This next one, assuming it's one of these three shapes, kite is the best fit there. And that formula was 1/2 d1 times d2. If you want to go back to those chapter 10 videos I made where I explain a little bit more each one why it is, it's really just half of a rectangle that would go around like that. The rectangle would be base times height, diagonal 1 times diagonal 2, but we take half of it because it's only half of that rectangle. So we have 1/2 times 14 times 12, and that would be 7 times 12 there, which would be 84 millimeters squared for the units on that one. On this one, if that's 5 and that's congruent to that, that's 5. If that's 8, this is 8. And this is a rhombus here. We've got diagonals that bisect each other. So we can make that assumption. If you were to do Pythagorean theorem each time, each one of these would end up being the same because they're both going to be the square root of 5 squared plus 8 squared. So we've got 1/2 d1 d2, once again, was the same formula as a kite, but it works for rhombi as well. And so we've got 1/2, and then d1, length of diagonal 1, I'll call that. This one would be 8 plus 8, or 16. And then the other one would be 5 plus 5, or 10. So we've got 1/2 of 16 times 10. Half of 16 is 8. 8 times 10 is 80. So we'd have 80 feet squared on that one. And then this final one looks like a trapezoid here. We've got area for a trapezoid, base 1 plus base 2 divided by 2. In other words, the length of the mid-segment of the trapezoid, times the height. Plug in what you know to find what you don't. So we've got 9.5 plus 29 divided by 2 times the perpendicular height connecting those two bases. It is 23. And so that would leave me with, looks like 38.5 divided by 2 times 23. Since I'm just rounding to the nearest tenth, I will take that, put it in a calculator, and end up getting, it looks like exactly 442.75 centimeters squared, and rounded to the nearest tenth, that'd be 442.8 centimeters squared. So either of those I would consider to be acceptable answers on that one. Moving ahead to the next slide, we've got find each missing length here. So a trapezoid has base lengths of 6 and 15 centimeters with an area of 136.5 square centimeters. What is the height of the trapezoid? So I would say, as I pretty much always do with these kinds of problems, write out the formula in general with nothing filled in yet, and then fill in what you know, plug in what you know to find what you don't. So we've got length of the mid-segment, average of the bases, times the height. We know the area is 136.5. We know the base lengths are 6 and 15, so that can go in place of B1 and B2. And then we are just solving for H here. So it looks like this would be 136.5. This would be 21 divided by 2, which would be 10.5, times the height, so 10.5H. So at that point, you can divide both sides by 10.5. That would cancel there and there. And that leaves you with your height. And the height Let me just double check this with the calculator a second and make sure we're all good here, and we are. So this is height is 13 centimeters. You could take that, plug it back into your original formula, and see that it works out. All of these problems that are like that, as long as you're doing the process right, you should be able to plug things back in to check. So one diagonal of a kite is 4 times as long as other diagonals. So I would say maybe something like this would be a good picture to apply there. So if this is not drawn to scale, once again, not my best to scale picture by any means, but if that's x, one of the diagonals, we'll call this one of the diagonals, and this other one x from there to there, this is 4x from there to there. So we're looking at the area of a kite, 1/2 d1 d2, plug in what you know to find what you don't. 72, 1/2, and then d1, let's call it 4x, and d2 x. If you flip-flop the order of those, it would not make a difference. You've got 72 would be 1/2 of 4, which is 2, and then x times x is x squared. You can divide both sides by 2, and you'd have 36 equals x squared, and then you can take the square root of both sides to get your answer. That would cancel out there, and so x, which is the length of the shorter diagonal here, so I'll call that, I refer to the shorter diagonal as d2, so I'll be consistent with that. d2 would equal, this is 6, and we're talking about meters there, so d2 is 6, and then to find d1, d1's 4x, so you can do 4 times 6, so d1 would be 24 meters. And then from there, number 16, the area of a trapezoid, or a trapezoid, we're talking about area, so I'm going to start with that same basic formula, b1 plus b2 over 2, average of the bases, times the height. I know that the area is 264, so that goes in right there. The height is 24, so I'm going to replace h with 24 this time. And it has one of the bases as 4. The other one, which I'll refer to as b2, is unknown. So we have this as our formula here. So there's a few ways you could approach this. You could, think PEMDAS, you could do 4 divided by 2 and b2 divided by 2, so you could call it 2 plus 1/2 b2 times that. But we're multiplying everything by 24 over here, everything that's here by 24. So if I just divided both sides by 24, I see that as, I think, the most efficient and effective way to get to a final answer here. And so 264 divided by 24, that should be 11. Yep, so we've got 11 is 4 plus b2 divided by 2. And then from there, if I want to get rid of the fraction, I can just multiply both sides by 2. That goes away. And then I have 22 equals 4 plus b2. So at that point, just subtract 4, and you should have your final answer of 18. So 18, this would be in meters, would be the length of your second base. Plug that into the formula with all the numbers that you know, along with this one now, and it works out. So yeah, that's a way you can check your answers. So finding the area of each circle now, we've got area is pi r squared for circles. If that's 18, that's referring to that whole diameter there. This would be 9 and 9 for a radius here and a radius here. Plug in what you know to find what you don't. You'd have pi times 9 squared. This would be 81 pi as an exact answer. It is saying in the directions to round this off each time, so that is 201.1 centimeters, not centimeters, 201. I'm looking at the wrong problem here. This is why I double check with my calculator. So looking at the wrong problem on the key. 20, so 81 times pi, there we go, 254.4. So 254.4 inches squared. And then this one, they just give me the radius directly, no computation necessary to just go ahead and plug that in. So 10.5 going in for r, 10.5 squared, that'd be 110.25. 110.25 pi would be an exact answer. And so if I multiply by pi using the pi button on my calculator and not 3.14. That's rounded off too much for the purposes of our class. We'd have that 346.3, or that's actually rounding off to 346.4 on that one. So that would be meters squared to the nearest tenth. Number 19, finding the area of a circle if the circumference is 16 pi. So we know a circumference formula is 2 pi r. So I'm going to plug in that 16 pi in for C. You've got 2 pi r, and I can solve for r from here. I'm going to divide by pi first to get all the pi's to go away, make this problem look a lot easier or be a lot simpler to calculate. If you did divide by 2 pi all at once, make sure you put that in parentheses if you're using a calculator to do the work for you. Otherwise, PEMDAS is not being done correctly. So then dividing by 2 leaves you with 8 equals r. That then can be plugged in into your area formula, pi r squared. To get the area is pi times 8 squared is 64 pi, and that rounded off, that's where that 201.1 that I wrote down earlier by mistake comes into play. So we've got that many centimeters squared. For number 20, diameter of a circle is what we're trying to find, and the area is that. So the area is pi r squared, that's the formula. I've got 1134.1 would equal pi r squared. And so now I'm solving for r from here. It looks like dividing by pi would take me one step closer to getting r by itself. Then I've got 1134.1 divided by pi. I'm going to leave it like that for now, would be r squared, and let the calculator do the work for me. So I'm going to take the square root then of both sides, put this into a calculator, and that means the radius would be approximately, and let me just double check that with my calculator here. So dividing that by pi, I've got 18.99987, so extremely close. If I round that off, I'm going to write it like this. I'll go to 5 decimal places for now. And then this, if I multiply by 2, that will be the diameter. So I'm just going to keep what I had in the calculator and hit times 2. So I've got 37.9997497, rounded off to the nearest tenth, and you have your diameter value as approximately 38.0. So 38.0 millimeters, not millimeters squared. Diameter is just a length, not an area. And so from there, we've got another one similar to that. Area of a circle is 706.9, and we're trying to find the radius now. So on this one, it will be just like this one, except we won't need to multiply by 2 in the end. You can divide by pi to get rid of the pi there. Then you have 706.9 divided by pi would be r squared. Then you can take the square root of both sides there. Square root and square cancel right there, and you're left with r is approximately, and let me just once again type this into my calculator, 706.9 divided by pi, square root of that, 15.00044, rounded to the nearest tenth, 15.0 inches. Number 22, area of a sector now, of each shaded sector. So the area of a sector is very similar, the formula, to the area of a circle. It's just a portion of that circle though. So I had written it as x over 360, the degrees you want or care about or that are in the shaded portion out of the total circle would be 360 times what the whole area would be, times pi r squared. So this would be 51 over 360 times pi times 2 squared, and this would be, then you could just type that into a calculator from that point if you wanted to. On the key that's going to be handwritten online, they show it the proportion way instead, or it's shown in that sort of way instead if you prefer, but I will just use this way because this way is just the way I have taught it myself. So if I type that in, I've got rounded off to the nearest tenth, 1.8 meters squared. So the proportion way gets you the same answer in the end. On this one, x over 360 becomes 130 over 360 times pi r squared, so times pi times 18 squared. And again, we can just round off to the nearest tenth, so you could stop right there. If you did have to get an exact answer, you reduce this fraction, multiply everything together, and do it that way. But we've got 130 over 360 times, and 18 squared is 324, so times 324 pi, and we'd have 367.6 approximately. 367.6 meters squared for number 23. And then number 24, it looks like 243 is the number of degrees there. If it said to do this part instead, and you got this as 243, hopefully you're thinking 360 minus that gives you that part, but we are just doing this part here. So if it told you, for instance, this was 117, then you do 360 minus 117 to get the shaded part. Be careful, there might be something like that on the test where you have to consider that as you do this. So be careful that you're doing the shaded part, not the non-shaded part instead. So 12.5 squared, going in for the radius squared, putting that into a calculator. Let me once again just double check that I'm getting the same answer, even though the key I'm looking at is doing things in a slightly different way. So times 12.5 squared times pi, and it looks like I am. So 331.339 rounds off to 0.3, not 0.4. So 331.3 meters squared. Next up, we've got Jason making a spinner for a new board game he invented. The spinner is a circle divided into 8 congruent pieces. What's the area of each piece? So we just care about one of these pieces. I'll use yellow. Is that going to show up very well? That shows up decent. So we're just looking for the area of that part there. So I would need to know what's that degree measure. And if it's 8 congruent pieces, it's 360 divided by 8, which is 45. So we're talking about if we use that same formula, 45 out of 360, you could say 1 out of 8, and that would be totally right as well. It's 16 all the way across. That means the diameter is 16, which means the radius is 8. So we'd have times pi and 8 squared. And so you'd have 1/8 times, this would be 64. So that would end up being 8 pi, which is approximately 25.1. Yes, so we've got approximately 25.1, and this would be in centimeters squared. 26 and 27 will take a bit of work here. These ones are those apothem and perimeter type problems. So we're going to be looking at, I'm going to split this up into this triangle here and here. I feel like that. There we go. I do have to freehand sketch this one. 6 is referring to that. For some reason, when I'm using this program and recording, it won't let me use the straight edge tool in here. So the way I had approached this, if you're one of my students, we talked about finding that angle first by saying it's 360 divided by the number of triangles you could make like that, which would be 6, and then split it in half because you're bisecting that with what we call the apothem there. And so that ends up being 30 degrees. So on this one, you could use trig, but I'm going to use the fact that this is a 30, and that's 90. That makes that have to be 60 degrees right there. So 30, 60, 90 triangle. This would be n. This would be n root 3, which is equal to your apothem in this case. And this would be 2n. And so we have on this one that the apothem is 6. And so we're trying to figure out if you're doing this the way that I had saw it this year at least. I had said it's the number of triangles, or it's the area of one triangle. So area of one triangle times the number of triangles you can make that are like that. So this is going to be 6. And then the area of one triangle, think of it as 1/2 base times height. So we've got 1/2 base times height times 6. This would be 1/2. And the base length, well, if A is 6 root 3, and that is the same as your height, it's the height of this triangle right here, we're trying to find out, this is n root 3 here. I'm sorry, that's not what I'm looking to say here. Apologies there. So A is n root 3, which is equal to 6, and the height is also the same thing as the apothem. So I could replace B with something that I'm about to figure out, but I could replace the height with 6. And then I can keep this as 6 as well, because there are 6 triangles like this. And so if A is n root 3 is 6, we can divide by root 3 to figure out what n is. And n is going to be this length, and there's 2 of them to find out the length of the base. So n, and then from there to there would be the length of the base of that triangle. So I've got 6 divided by root 3. I'm going to leave it like that for now. That's what n is, and that means the base would be 2 times that, 2 times 6 over root 3, which is equal to 12 over root 3. You could be typing this stuff into a calculator and approximating it. So I'm going to type it in directly though, and plug it in right there. So if you have 12 over root 3, that is your base. If you had been approximating that, so divide that by root 3, you're getting about 6.92820. So if you had that as your B, that would be great as well. If you just got the n part, or just this part, that would be 3.4641 and some change there. So if I take this and I type that into a calculator, so 1/2 times 12 divided by square root of 3 times 6 times 6, I get my answer of 124.7 feet squared. And if you had learned this the 1/2 perimeter times apothem way, 1/2 PA way, or AP way, we would be here finding out the base length and then multiplying that by 6. So we'd take this, or round it off as a decimal, multiply it by 6, and the apothem would be 6. If you do that though, you end up getting the same answer in the end here. So if you do it this way, totally fine, nothing at all wrong with that. You should get to the same answer in the end. So on this one, the side length here of one of these triangles is 10, and this would be my height. And on this one, I will figure out what this angle is first. So 360 divided by 5 divided by 2, that ends up being 72 divided by 2, which is 36. So we got a 36-degree angle here. This one, trig is definitely required to get to the answer. Only with hexagons does it work out that 30, 60, 90 triangles will end up occurring. Unless you have an equilateral triangle and use the same sort of idea, then it will be a 30, 60, 90 triangle, just with this being 60 in the central angle part instead of 30. But all that said, this is 36, that's 10, so I'm going to make for this blue triangle, if that's 10 here, this would be 10 here, so I'm going to make a copy of that same blue triangle, a little bigger down here. This is 36 degrees. If that's 36, that's also 36 right there. That's congruent to that. And then this is 10 right here. I'm trying to figure out this height, which you could also call the apothem. So I'll say A equals H here. And then I'm trying to figure out what is this length right here, which I'll refer to as X. Once I know what X is, then I can double that to get the base length to plug into my formula. So the area formula, area of one triangle times the number of triangles. If you prefer to do it the 1/2 PA way, you get the same answer in the end. No problem with that at all. So I need to know 1/2 base times height, and times, there's going to be 5 of these triangles, these big triangles that I can make like that. So I'm going to just write in times 5 right away. I've got 1/2 times whatever 2 times x will be, and then times the height. I don't know either of those yet, so I've got a little bit of work, side work to do on this one. So it looks like that's 36. Hypotenuse is 10. If you think sohcahtoa, We've got opposite over hypotenuse would be sine. So sine of 36 degrees would equal x over 10. You can think of that as over 1 cross multiply. You need to have x is 10 times sine of 36. And if we're trying to figure out what this apothem is, which is just the height of that triangle right there, we would be doing, I'll do this in orange instead, we'd be doing the cosine of, I think I'm going to run out of space here, let me get rid of that. Okay, so cosine of 36 would equal, and I'll refer to it as h, you could call it a as well for apothem if you wanted to. You can put that over 1 cross multiply, h would be 10 times cosine 36. So if I wanted the base length, which is 2x's, I could just double that and say that b would be 20 times the sine of 36. So I'm going to just take that and I'm going to take this and plug it into the formula up here. If you prefer to get a decimal approximation first, then I would either just keep it in the calculator or use 5 or more decimal places and put it in like that and get the answer from there. So for the base, it's 20 times sine of 36, or the decimal approximation equivalent of that. For the height, it's 10 times, not the sine, but the cosine of 36. And I've got that times 5. So this is going to be 200. I'm not going to try to do that in my head. So let's make sure your calculator is in degree mode for this. So just double check that it's not in radian mode, but is in degree mode instead. And then type that all into the calculator. So I'm typing in 1/2 times 20 times sine of 36 times 10 times cosine of 36 times 5. And doing that gives me the answer that matches up with what I see on the handwritten key, 237.8 rounded off to the nearest 10. So that'd be in centimeters squared. Moving on to number 28 then, find the area of the shaded region given the diameter of the circle is 20. So I've got all the way across, I'll draw a sketch of that here, all the way across from here to there would be 20 centimeters. And then from there, I'm really just trying to find the area of this triangle right here. But I also have a circle to consider there. So if that's 20, the radius of this is going to be 10 right here. And so if I focus on what I'll call the purple triangle, or what is the purple triangle right here, I'll draw another slightly larger sketch of that purple triangle here. If I'm going to refer to that, I'll refer to that as x from here to here, and then that would be another x from that point to that point. So the base length would be 2 of those x's. And so from there, we have, this is what I'll refer to as x. So it's x right here, it's x right there. This is 10. And we'll need to figure out what that angle measure is right here. So this angle measure would be 360 divided by 8 now. It's an octagon here in the middle. Divide that by 2 and you'd have 22.5. And so this is a 22.5 degree angle right here from there to there. And so we can use that information to help us figure out what the area of this triangle is going to be. So the area for this whole thing, the area of the shaded part, if I backtrack, look big picture a little bit here, it's going to be the area of the circle minus the area of the octagon. And so the area of the circle is going to be pi times 10 squared. And that's pretty straightforward. The area of the octagon would be the area of one triangle, so 1/2 base times height of this red triangle here, times the number of triangles that you can make like that, so times 8. If you prefer the 1/2 PA way, perimeter times apothem way, go ahead and do it that way as well. So now I'm just looking for what I'm I'm missing. We've got 1/2. I don't know my base length yet, but I know it's going to be double of whatever x is here. I don't know my height yet, but I know I can use trig to figure that out, and so I'm just going to figure those things out now. So it looks like I've got, on this one, I'd have, I'm going to call this h for height. You could also refer to that as your apothem right there, so a equals h, and it looks like we would have then sine of 22.5 would equal x over 10. We've got cross multiply, put it over 1. X would equal 10 times the sine of 22.5. I'm going to leave it like that, but you could approximate it if you wanted to. B being double that, being 2x, means that would be 20 times sine of 22.5 for the base. So I'm going to put that in right here. I've got 20 times the sine of 22.5. Feel free to round that off. If you're one of my students, use 5 or more decimal places, as I had been saying all along as we have gone through this. And then for h, you'd have cosine of 22.5 equals h, or apothem a, if you prefer, over 10. Cosine, you have adjacent over hypotenuse. Put that over 1. Cross multiply. H is 10 times cosine of 22.5. And so I can plug that in directly here. 10 times the cosine of 22.5. Close my parentheses. Or actually, I'll write times 8 from there, because it's that. So this is your 1/2, base in red times height in orange times 8 is the number of triangles like that. Putting all that into a calculator, let me double check what I have here against the key that you'll find if you're one of my students, handwritten online. So 100 pi minus 1/2 times 20 times sine 22.5 times 10 times cosine 22.5 times 8. And it looks like I have Looks like I have 31.3 if I put my parentheses all in the right spot. So 31.3 rounded off to the nearest tenth, and that would be centimeters. So 100 pi, just take pi and move the decimal place 2 spots. You've got a little over 314. Subtracting this ends up being 282.861 for the area of the octagon. If you do that separately and then do that way, that would be totally fine. Composite figures now. We're looking at figures like this. Area of each composite figure. The area of this would be the triangle plus, I'm going to call this shape 1 and shape 2. So the area of, whole area would be area of 1 plus the area of shape 2. And so we'd have a triangle. And if this is 20 all the way here, from there to there, and that's 5, that would mean you'd have 15 for this red part right there, and you've got 12 for that part. So we would have 1/2 base times height. I'm going to write the formulas in general first, plus base times height. These b's and h's aren't necessarily the same. They are dependent upon the shapes you're looking at. So this is 1/2, base is 12 for that triangle right here, and the height perpendicular to that would be 15. Plus base times height, that would be base of 12, but a height of 5 now, so for that rectangle. So we are looking at 6 times 15, 90 for that one, and then 12 times 5, 60. Put that together and you have 150 meters squared. For this one, we've got a semicircle. The diameter is 3, so this radius is 1.5. And then 7 feet from there to there. So it looks like we've got, I'm going to call this on this one, when I color code a little bit more here, I'll call that 1 and I'll call that 2. So the area of this whole thing would be the area of shape 1 plus the area of shape 2. So that's a semicircle. So it's 1/2 pi r squared for that part, and then this would be base times height, whatever the base and height of the triangle are. And so on this one, we've got 1/2 times pi times 1.5 squared plus the base is 3, and the height is 7. And so plugging that into a calculator, this would be 21. That looks like 2.25 times 1/2. So I'm not going to try to do that in my head. We've got 0.5 times pi times 1.5 squared plus 21 ends up being 24.53, and I forgot the 1/2 part here. That's where I'm going off now. So this is 1/2. I'll just put times 1/2 there. So let me type that in one more time. So I'm getting 14.0 then at that point. So 14.0 feet squared. And then this one, it looks like a rectangle, but subtracted from that is this semicircle. So this, it appears we have to make an assumption here. No, we don't. This is 8 here. So it's a safe assumption to say that if that's 8 and that's 8, this would be half the length. The radius would be half here to here as it is here to here. So if that's 4, that's 4. It doesn't matter what radius you look at. That would be 4 inches for that. So I'm going to say that this now is shape 1, and shape 2 is the whole rectangle. That's what I'm looking at in this case. So the area of this is going to be the area of shape 2 minus the area of that semicircle, shape 1. So we would have base times height would become 8 times 8 minus the area of 1/2 pi r squared. It's a semicircle, half of a circle there. So we've got minus 1/2 times pi times 4 squared. So it'd be 64, and that would be minus 8 pi. And so 64 minus 8 pi, put that in a calculator, we've got 38.9 for that. So about 38.9 inches squared. Continuing from there, it looks like we have on this one a rectangle, plus if you think of this and this together right there, that makes a single circle with a radius. If that's 15 from there to there, the radius would be 7.5 for that circle. So I'm putting two semicircles together and getting a whole circle. I'll call this shape 1, and then this is kind of like 2 and 2 put together to make a whole circle. So the area of this whole thing would be the area of 1 plus the combined area of the two semicircles makes a whole circle. So we'd have base times height plus pi r squared. This would become 30 times 15 plus pi times 7.5 squared. And it looks like that'd be 450. And 7.5 squared is 56.25. So we'd have that times pi plus 450 ends up being 626.7 centimeters squared. And finally, moving on to the problems on the last page here, we've got now surface area problems and lateral area problems as well. So we've got naming the figure, find the lateral area and surface area for each, round all final answers to the tenths if necessary. So on this one, it's not quite a cube. This is 10, 12, and 12, but it is a rectangular prism. Lateral area formula was perimeter times height for that. So figure out what your base is. I'm going to call it the top and bottom on this one. These are the parallel planes, Pert or congruent faces in parallel planes on that. You could use left and right or front and back for prisms, but we'd have 12 plus 10 plus 12 plus 10, and then that times the height connecting those would be 12, and so this would be, it's like 24 and 44 times 12, 44 times 12 there, and so we'd have for that 528, and this would be, so I'll write that in right here, 528 yards squared. So yards squared for that. And then surface area is that lateral area plus the area of the two bases. So we could just plug in 528 right there, and then we'd have 2 times 12 times 10 And that I'll just write in there. So 2 times 12 times 10, that'd be 240 added to 528. So we're looking at 768 yards squared. So 768 is the answer going in there. For this one, we've got lateral area of a cone. That formula was pi r L, L being the slant height. So you can replace r with 5. L is right here. The height on a slant is 14. This is a straightforward one because of that. So you've got 70 pi, which is approximately 219.9 on that one, 219.9. And so we can put that in right here. I should have written a cone on this one, so then 219.9. I'll just be putting the units on these lines here and not including them there. So that would be meters squared. And then surface area for a cone is going to be that lateral area plus with just one base now. We just have a single circular base, so it's plus pi r squared. So we would have 219.9, or the 70 pi to be more specific, and then pi times 5 squared. This ends up being approximately 298.5. 298.5 for that answer. So 298.5 meters squared. This right here is a pyramid, and we're looking at lateral area. And if you're just using L instead of LA, that is fine, nothing wrong with that. If that's 12 and it's 14 from there to there, that would make this 7, and we're going to be needing this slant height eventually on this. So I'm going to do some side work here. You'd have 7 squared. Sorry about that, I didn't mean to put that right there. For this red triangle right here, 7 squared plus 12 squared would equal, this is that cursive L for slant height squared. So you'd have 49 plus 144 is the slant height squared. Means slant height squared would equal 243. So the slant height itself would be, take the square root of both sides. We're looking at the square root of, and I'm writing 243. Boy, I'm trying to go a little too fast here. I've had my mind on something else there for a moment. That's 193. Sorry about that. So square root of 193. And so lateral area for a pyramid was 1/2 perimeter times slant height. And so the perimeter of this would be 14, and you'd have 4 of those. So 14 plus 14 plus 14 plus 14, or just 14 times 4 for perimeter, and then the slant height, square root of 193. And putting that into a calculator looks like gives you 388.988. So if you round that off, that'd be 389.0. So I'm going to have that going right here, 389.0 feet squared. And then surface area is going to be that plus the base area. And so that was 389 plus area of the base would be 14 times 14. You've got a square base, which is just a special type of rectangle, so just base times height. And so we're looking at approximately 585.0 for that answer. So 585.0. Sorry for the messiness there. 585.0 feet squared. And you could call this a square pyramid as well. The key online, it might say cube on this one, but because that's 10, it's not. So that you might see a mistake on that. So I'll put square in parentheses above this. So rectangular prism cone, square pyramid. On this one, it looks like we've got a cylinder that has a diameter of 12, so the radius is going to be 6 there. And lateral area is just perimeter times height, which is same as circumference times height, which is 2 pi r. So we have 2 pi r h. We've got 2 pi times 6 times 10 for the height. That ends up being 120 pi, which rounds off to approximately 377.0 if you round to the nearest tenth. So 377.0 inches squared. And surface area is going to be that, 2 pi r/h, or just lateral area. So I'm just going to replace that with what I already calculated it to be, plus there's going to be two bases, or two circular bases. So 2, that's a base, 2 pi r squared. This would be that then, plus 2 times pi times 6 squared, and plug that into a calculator, round it off to the nearest tenth. You end up getting 603.2 inches squared. On this one, the lateral area, and this first of all is a triangular prism because you have two congruent parallel faces here in the triangles connected by these rectangular lateral faces. So we have a triangular prism. You're going to have perimeter times height for the formula there. The perimeter of this looks like would be 9, 9, and 9. So you have 9 times 3 for the perimeter of the base. Whoops. So the triangles are the bases, times the height is the height connecting the two bases. So times 12, this would be 27 times 12, which would be 324 exactly. So you have 324, and this would be centimeters squared. Your surface area is going to equal that lateral area plus the area of two bases. So we've got 324 plus, and you have 2 times, and then for each triangle it's 1/2 base times height, so 1/2 times 9 times 7.8. So each of these triangular bases is going to have that as the base, and multiply by 2 because there's 2 of them, and then we're looking at 394.2 centimeters squared as our answer. And then on this one, we've got this slant height right here. That is L right there for this hexagonal, or I should say hexagonal, not hexagon, hexagonal pyramid. And so to find the lateral area, we would need to know 1/2 times the perimeter times the slant height. So that should be pretty straightforward. You've got 1/2 times 8 times 6 is your perimeter for the base. This is your base down here, this hexagon, times the slant height, which is 20. So if you have half of 20, that's 10. 10 times, this would be 48, would be 480 for your lateral area. So 480, and that is in inches squared. The surface area is a little bit, got a little bit more to it here. You're going to have to find that area of that base. So we have to use either that 1/2 perimeter apothem idea, or you have to split it up into 6 triangles, find the area of one of those triangles. So we have lateral area plus the area of one base. So we're going to replace lateral area with 480. And then we're looking at this hexagonal base. This is a very rough sketch here. Oops. And so we're looking to find the area of this little part. I'm really thinking of that triangle right there. We've got 6 of those triangles like that. Because this is a hexagon, you could do this calculation. 360 over 6 divided by 2 becomes 30. So if I look at this red triangle, that's 30. That means that's 90 and 60. So you could call this 2n for that part. You could call this n root 3 for that part, and you could call that n. And which one of these do we know? We know that this whole length from there to there is 8, so that means this would be 4 and this would be 4. So we know the n part, which makes things pretty straightforward from there. So n is 4. That means the 2n, we don't really care about that. That'd be 8, but we care about this part, the apothem, or the height of this triangle, is going to be equal to 4 root 3. And then the base length is already known as 8. So we've got plus, for 1/2 base times height for each triangle, would be 1/2 times 8 times 4 root 3. and then times the number of triangles I have, I could make 6 triangles like that. So if I plug this into a calculator, let me just double check that at this point, 480 plus 0.5 plus, or times 8 times 4 root 3. And you could use trig on this as well. I don't want to make you feel like you can't do that. If you wanted to use trig to set up like sine of 30 would be opposite of hypotenuse, you'd have that. We'd have 646.3 inches squared, though, if you round it off to the nearest tenth on that one. If you use the 1/2 perimeter times apothem way, you should get the same thing. And then 2 more from there, and we are all done. So we've got, for this one, looks like we have a cone. The lateral area is going to equal pi RL on that. And so you'd have pi times 10 times slant height. You'd have to do a Pythagorean theorem calculation for that, it looks like. So L squared is going to equal 10 squared plus 25 squared. That means L squared would equal 100 plus 220, or plus 625 rather, sorry. So L squared is 725, so that means L is the square root of 725. So we can take that and plug it in here. We'd have the square root of 725. Put that all into a calculator, and you're looking at approximately 845.9. And so 845.9, I promise that's a 5. Sometimes it's hard to write with this tablet that I'm using, but we have feet squared with that. And then surface area would be that lateral area plus the area of the base. So we could say 845.9 here. I would just keep that in the calculator, what you had before, and then add a pi r squared to that. So add pi times 10 squared to that, or 100 pi, and you end up getting 1060.1 for your answer for that. So 1060.1 feet squared. And then finally, for number 40, it looks like finding the surface area of this figure below. We're going to have this rectangular prism on the bottom, so I'm going to refer to that as kind of like shape 1. And then we've got this half a cylinder up here, shape 2. However, this rectangle will not be visible. So you're going to have a missing rectangle here for what would be the normal surface area of 1, and then you'll have a half a cylinder, so that usually isn't calculated, this rectangular part in the cylinder, so we'll just take whatever half the surface area of a cylinder normally would be for that. So the whole surface area is going to equal the surface area of 1 that is showing, that's appearing, plus the surface area of shape 2. So we're going to have what normally would be perimeter times height plus 2b, but in this case only one of the bases is showing. If I call this my b, and there would be another base just like that for this rectangular prism, I'm just putting 1b instead of 2b because this one is not going to be showing. It's going to be covered up by that cylinder on the top, so not 2b here as it normally would be. And then this one, surface area of a cylinder, typically we would have lateral area, which is 2 pi r h plus 2 pi r squared, but we're going to be dividing that by 2 in this case because we only have half a cylinder. And so if we do the calculations here for that one, perimeter would be 36 plus 48 plus 36 plus 48 times the height connecting the, I'm just looking at the prism part here now, times 18 plus the area of the base, which would just be 36 times 48. So this all is just this part here. So right here is this part from there to there, and then this part in orange here I will underline over here. We would have 2 pi rh, so that's 2 pi times, if that's 36 all the way across, that would make that 18 for the radius. And then h, the height of this connecting from here to here is 48. plus 2 pi r squared. So plus 2 pi times 18 squared. All that divided by 2 is going to be that part. So that's number 1 if I'm going like that. So that's the area of surface area of portion 1 or shape 1 there, and then shape 2 or portion 2 there. So let me do a little bit of simplification here. 36 plus 36 plus 48 plus 48 ends up being 168, and then that times 18, and we'd have 36 times 48 for a total of 1728, and then here 18 times 48 times 2, we'd have 1728 pi, and then 18 squared times 2, we'd have 648 pi right here, all that divided by 2. So I'm continuing to simplify here. This would be 3024 plus 1728 in the next step. So for that red part, 4752 looks like is what I've got there for the first part, or shape 1, and then for shape 2, 1728 plus 648, 2376 pi, and then if I divide that by 2, I've got 1188 pi for that part. So hopefully I've done all this right. Let me double check what I've got against my key here. And if I add that to that, yes, it is correct. So this is 8,484.2 inches squared for the final answer for that. Whew! That was a lot to take in there, a lot to do, but the video is complete. If you wanted to watch the whole thing and you found that useful, great. If you wanted to just skip around and just find the ones that are useful to you or helpful to help you understand what was going on, I think that's the most ideal way to use this. But hopefully you found that helpful, and hopeful, I think as well. Hopefully you tried the problems yourself first and then referred to the ones you needed help on, or just reviewed it to kind of watch the whole thing to kind of soak it all in and take it all in before you take your Chapter 10 test. If you have any comments, please comment on the video, or if you're one of my students, send me an email and I'll get back to you as soon as I can. And I hope you have a good day, and I hope the test goes well for you.